Okay, so we're going to do question 4.6. So a person purchases a dozen eggs and must take them home. Although making trips home is costless, there is 50% chance that all of the eggs carry on one trip will be broken during the trip. So the person considers two strategies. Strategy 1 is taking the whole dozen of eggs in one trip, and strategy 2 is making two trips and taking 6 eggs in each of the trip. So part I ask you to list all the possible outcomes of each of the strategy and the probabilities of these outcomes. Show that on average 6 eggs is going to make it home under either strategy. Okay, so we are going to go with strategy 1 first. Alright, so strategy 1 we got over here is outcome and over here is probability. Okay, so taking the 12 eggs in one trip, and so 50% chance all of the eggs is going to be broken, and so we got 0 eggs. Okay, with the 50% probability, and 50% chance all of the eggs is going to be fine, and we got 12 eggs. Okay, with 50% chance. Alright, so the expected value in this case, or the average number of eggs, okay, is going to make it home is going to be 0 eggs times 50% and 12 eggs times 50%, and that's going to be equal to 6. Okay, so the expected value or the average number of eggs is 6. Okay, that is going to make it home. Now strategy 2. Okay, so this case we got 2 trips. Okay, now trip 1 first. Outcome and probability. Alright, so for trip 1, 6 eggs is going to be taken in the first trip. 50% chance again, all of the 6 eggs are going to be broken, so we got 0 egg. Okay, with 50% chance, and 50% chance 6 eggs is going to be 5, so we got 6 eggs. Okay, that's for trip 1. Now very similar for trip 2. Again, 50% chance all of the 6 eggs on trip 2 is going to be broken, and we got 0 left. Okay, and 50% chance chance all of the eggs is going to be broken, and we got 0 eggs, and 50% chance the 6 eggs are okay, so we got 6 eggs left. Okay, so that's for trip 2. So as you can see over here, we in both the trips we are going to have total 4 cases. Okay, so the first case is where all of the eggs are broken in the first trip and all of the eggs are broken in the second trip. Okay, which is the case over here. So this is the case. So 50% for the first trip, 50% for the second trip. So so therefore the total, the final is 25%. Okay, which is the first case at which all of the eggs are going to be broken in both the trips. Okay. Alright, so therefore the expected value is, or I would say I got 4 cases in total. Okay, so the first case is 0 egg in trip 1. Okay, and 0x in trip 2. Okay, so the total outcome is going to be 0x in both the trips. And the probability in this case is 50% for the first trip times 50% for the second trip, so that becomes 25%. Okay, remember 50 is 0.5 times 0.5 is 0.25. Okay, now case 2 is the second case, so 0x in trip 1, okay, which is here, and 6x in trip 2, so that is the second case. Okay, so the outcome in this case is going to be 6. Okay, we got none in the first trip, however we got 6 in the second trip, and the probability in this case again is 50% chance in the first trip, 50% chance in the second trip, so it's 25% chance. Alright, in case 3 we got 6x in the first trip, okay, and 0x in the second trip. Right, so as you can see, that is the case over here. So 6x in the first trip and 0x in the second trip. Okay, so that is the case 3. So the outcome in this case again is just 6x in total. Okay, from both the trips. And again, probability is 50% chance in the first case, in the first trip, and 50% in the second trip. So it's happened with a 25%. Okay, and the last case here, we are going to be able to keep 6x in the first trip and also 6x in the second trip. Alright, so that is the last case over here. We can see, so 6x. Okay, and 6x. Right, so the total number of x in this case is 12. Okay, so all of the x are fine, and the probability in this case is again 50% chance of 6x in the first trip and 50% chance of 6x in the second trip, so 25%. So as you can see, we got 4 cases, and each of them happened with 25%, which is equal probability. Alright, so therefore the expected value in this case is 0x, that's happened with 25%, 0.25. 6x happened with 25%, and another 6 happened with another 25%. So as you can see, outcome 6 over here is happening with 50%. Okay, so 6 times 0.5 plus the last one, outcome 12, come with 25%. Okay, so the expected value is 6 times 0.5 plus 12 times 0.25, which is 6. Okay, so as you can see, the expected value is 6x again. Alright, so this is basically show that in either case or in either strategy, 6x are going to make it home. Alright. Alright, so 6x make it home on average. Alright, so part B asking you to develop a graph to show the utility obtainable under each strategy. Okay, so we will let UX be the utility x, where x is the number of x. Okay, the number of x that are not broken. Okay, so because the question doesn't tell you anything about a utility function, so we will just be assuming that the utility is a normal convention concave function of x. Okay, so over here we assume that ux is a normal strictly concave function of x. Okay, so now if the question doesn't tell you anything about a utility function, we assume that we have a well-defined convex preference that is going to be represented by a conventional concave function. Okay, so represent a well-defined convex preference. Alright, so so before we want to show the utility on the diagram, we would like to find out what is the utility, or what is the expected utility under each of the strategy first. Okay, so I got strategy 1. Now we know that strategy 1, 50% chance x is going to be equal to 0, and 50% chance x is going to be equal to 12. Okay, so therefore, okay, so I got 50% chance x is 0 and 50% chance x is 12. Alright, so therefore the utility under this case, I would say this is the utility 1. Okay, it's going to be equal to 50% chance utility under the case of x equal to 0, which is u 0, okay, plus 50% chance the consumer got 12x, and the utility is going to be u12, and so that is the expected utility under the first strategy. Okay, now I do not have the utility function, so I should not be able to find out what value this one is. Okay, however, I can just leave it like that. Okay, I'm going to show it on a diagram later. Okay, so we come to strategy 2. Alright, so we know that strategy 2, 50% chance for the first trip. Okay, we are going to get we already know from before that 25% chance x is going to be equal to 0, 25%, so 50% x is going to be equal to 6, and 25% x is going to be equal to 12. Okay, so therefore utility 2, which is under strategy 2, is going to be equal to 0.25 utility of 0 plus 0.5 utility of 6 plus 0.25 utility of 12. Okay. Okay, so I'm going to draw the utility under two strategies in a diagram over here. Okay, so what I got is on the vertical I will have the utility u, and on the horizontal I will have the number of x, okay, that are not broken, so basically the number of x that are making home. Alright, so I got 0x, over here I got 6x, and over here I will have 12x. Right, so like I said before, we assume that we have a normal concave utility function, so my utility function will just be like this. Okay, at 0x the utility is going to be equal to u0. Okay, now 6x, so if we go all the way up to our utility function, we are going to get a utility of 6x. Okay, so this is utility of 6x. Okay, and if you get 12 over here, go all the way up, okay, you're going to get a utility of 12x. Alright, so we are going to draw the utility of the first strategy, which is half of utility 0 and half utility of 12. So as you can see, that is going to be just the midway between u0 and u12. Okay, so half of each. So if I use a straight line and I connect these 2 points together over here and here, okay, then the middle point is just going to be halfway between the utility. Okay, so over here is u1. Alright, so u1 is just basically halfway between u0 and u12. Okay, or it's just corresponding to a point over here. Alright, so that's the utility in strategy 1. Now the utility in strategy 2 is over here. Okay, and I would like to draw this on a diagram. Now as you can see, it's a little bit more complicated because we got 25 over here, but if you are looking at it carefully, you can see that it's just basically the midway between the midpoint of u0 and u6 and the midpoint of u6 and u12. Okay, so if you're following me, I'm going to use a red color to indicate that. Now if I take the midpoint between u0 and u6, so if I connect these 2 points together and I get a midpoint of those, which is over here, okay, so at this point over here, the utility at this point is going to be just half of u0 plus half of u6. Okay, so this is just the midway between u0 and u6. Now if I use another straight line and I connect the 2 points between u6 and u12, connect these 2 points together. Alright, what I do is I just have to adjust this. Okay, so if I connect these 2 points together and I get the midpoint between these 2 points. Alright, now I know that this midpoint over here is just going to be halfway between u6 and u12. Okay, so this is half of u6 plus half of u12. Okay, now in order to get the utility under strategy 2, I just have to get the midpoint between these 2 points. Okay, so I'm going to use a blue line and I connect these 2 points together. Alright, then the midpoint between these 2 points is going to give me the utility 2. How do I know that? How do I prove that that is the case? Okay, so easiest way to see is, okay, I know that this is the point, so the point over here is u, okay, 0.5 u0, okay, plus 0.5 of u6. Now the point over here is u 0.5 of u6 plus 0.5 of u12. Okay, now what I did just now is I take the midpoint between these 2 points, okay, between this point and this point over here. So if I take, so the midpoint basically mean I get half of this, okay, plus half of this point. Okay, so now if I expand everything, I would like to see whether this is going to give me the point that is exactly the same as the utility 2 over here. So if I expand, I get 0.25 u0 plus 0.25 u6, okay, plus 0.25 u6 plus 0.25 u12. And so that is just going to give me 0.25 u0 plus 0.5 u6 plus 0.25 u12, and that is exactly utility 2. Okay, so I know that utility 2 I got over here is just the midway between these 2 red points. Okay, because using the calculation I can prove that it is the case. So therefore, in terms of the diagram, u2 over here is just going to be halfway between this point, this red point, and this red point over here. Alright, now so if you compare utility 2 and utility 1, you can see that utility 2 is higher than utility 1. Okay, indicating that under the strategy 2, the expected utility for the consumer is higher, or the consumer is better off using the strategy 2. Okay, now part C asking you, could utility be improved further by taking more than 2 trips? So as you can see from a diagram, the more trip the consumer is going to make, the higher the expected utility is going to be, which is basically the smaller the segment that we are going to have. Okay, so instead of having 2 segments, 2 red lines over here, we are going to have a little more of the little lines. Okay, and by connecting those lines together, those midpoints together, we are going to get a higher utility. So basically, now anyone want to prove that, you can just take the case where the consumer taking 3 trips, and each of them the consumer is taking 4x, for example. And if you keep doing that, you applying the same rule and you drawing that on a diagram, you can see that the utility in that case is going to be higher than the utility 2 or utility 1. Okay, so the more trips that the consumer is going to take, the higher the utility, or the higher the expected utility is going to be, because basically it reduces the risk of losing everything, or the diversification is basically making the consumer better off. Okay, so I will say okay, so given that it is costless, okay, for the consumers to make trips, it is, I will say, the utility okay could be improved further by the consumer taking more trips. Okay, or to be more precise, the more trips that the consumer takes, the better the utility is going to be. Okay, more trips, higher utility. Okay, due to the fact that it is less risky. Okay, for the consumer, or the deficit or the diversification is going to make the consumer better off. However, if additional trips were costly, how's that going to affect the desirability of this possibility? So we know that the more trips that the consumer is going to make, the better the utility is going to be. Okay. However, the extra utility that the consumer is going to get, how's it compared to the extra cost that the consumer will have to pay for the additional cost? So then you would have to compare those two together. Now, if the additional cost is higher than the additional utility that the consumer is going to get from making more trips, then the consumer wouldn't want to do so. Okay. However, if it is costly to make trips, then the extra utility from making an additional trip it has to be compared to the cost of an additional trip. So if the cost is higher than the benefit, or from the is higher than the extra utility, then the consumer wouldn't want to take the trip. Okay, so therefore if the cost is higher than the extra utility, then the consumer will not will not want to take the trip. So by having the trip being costly now, that is going to make it possible to have a maximum number of trips. So as before, if the trip doesn't cost anything, then the more trip the consumer is going to make, the better he is going to be. So it's unlimited numbers of trips that is going to make the consumer better off. So the more trip he takes, the better he is. There isn't any limit number of trips. However, if it's costly to make trips, then we might be able to find a maximum number of trips, because beyond that the cost is going to exceed the benefit, and the consumer wouldn't want to take any more trips. So I'll say there might be an optimal number of trips that the consumer wants to take. Is not unlimited like before anymore. Not unlimited number of trips as before. Right?